this. I do. I got it. All right. Today we actually have a lot to cover. But I think it'll be a good amount that we're covering today. We're getting ready for assignment 2. And do you guys remember we talked a little bit about assignment 2 last week? Do you remember what's different in assignment 2 over what we've done assignment 1 on? What's the main difference? We spent a lot of time talking about it over the last 2 weeks. This will be on the quiz, just so you guys know.
It has an API gateway?
Yes, it has an API gateway. Good. Why? Why are we doing an API gateway?
Or breaking apart the monolith. Start good.
Yep. Breaking apart the monolith and creating what?
Asynchronous, tiny little microservices.
Microservices. Yeah. We're moving from monolithic to microservices. Asynchronous is part of that for sure. If you're asked the benefits, and go back and listen to those, the benefits of microservice and also the cons. Not everything's perfect with microservices. There's a lot of overhead involved, harder to debug, but the benefits outweigh some of those issues that we're having with the monolithic, which is scalability, reliability, and those sorts of things. That's the sort of thing that you guys are going to see on the quiz. Guaranteed. Absolutely guaranteed. Okay. So just real quick, when we're talking about microservice, and I think Hamza already mentioned this, it means that there's an API gateway. And we talked a lot about the API gateway last time, and what that looks like in Java, in Spring. And today we're going to focus on the service registry. And we're also going to, and the service registry we're going to use is called Eureka. It's a discovery service, really, really easy to use. And we'll talk about the philosophy around discovery services and the principles, and then we'll also see how to configure that. Then we're going to talk about reactive programming and what is reactive programming. Next week, we're going to go into some programming paradigms in Java for reactive programming. But today we're going to talk about what it is and why it's useful and the benefits. Okay. And then if we have time, we'll take a look at assignment 2 again. And specifically, I'm going to show you guys stuff halfway through the middle. You'll want to, if you drop off, oh, it's going to be so bad if you drop off early, because I'm going to show you how you guys can use ChatGPT to help you with assignment 2A. It will make your life so much easier if you use ChatGPT. And I'll show you how to do that. And there's already a video out there on how to do that as well. You'll hear my perspective, and you'll hear Dr. Schmidt's perspective on that as well. So that's what we're going to cover today. Okay. Anything that anyone has any questions with before we drop into this? Any questions? All right. I'm going to be asking lots of questions of you guys today. Remember, this is a simple microservice architecture. It's not the only one out there. It's the one we're going to focus on in this class right now. We're probably going to add, I'm going to add some additional microservice architectures for you guys to look at so that you can see what other ones look like as well. So when you see them out in the wild, you recognize them as a microservice architecture. But this is a basic one that we're going to use. And you'll see that all the other microservice architectures are kind of built off of this. This is like the foundational one that everyone uses. Okay. Key elements is that I have microservices out there that do a specific thing. I have an API gateway, and we'll talk about real quick question for you guys. Why do we want an API gateway? What are the benefits of an API gateway? Anyone? Anyone remember the benefits of an API gateway?
It acts as an orchestrator or router to the respective service.
It does, but why have one of those?
Load balance.
Load balancing, very good, Hamza. Who else?
It has like a single. Oh, sorry.
Go ahead, El.
It has a single entry point.
Single entry point, right? Perfect. That isolates the client from the back end architecture, which is really important. Okay, so those are some of the benefits. We'll talk a little bit more about that with the service registry. Service registry, we're going to go in depth today. The service registry does what? Anyone have any ideas? Or just read the slide to me.
It enables an API gateway to find and communicate with backend services.
Thank you, Aaron. So what in your own words, Aaron, what would you say a service registry does?
I mean, it keeps track of where your services are at. So you don't
Right.
have to, so you're not out there updating environment variables with like base URLs and things.
That perfect. Because the service registry is keeping track of where the services are, it means that my services are no longer tied to a specific host or IP address, which means if a host goes down, I just put that service somewhere else. I'm off to the races. Service registry will now know where that new host is and that host and port ID for that service and tell the API gateway, and we're reconnected. No big deal.
So can I ask a question about the service registry thing? Because
Yeah.
to tell you the truth, we don't use one of those. And I'm kind of wondering if this is something that's mostly used in like Kubernetes or one of those, I forget what the other
Docker.
Docker Swarm or whatever. Is that the real use case here? Because when we deploy stuff out to VMs or Azure App Services or Cloud Run or whatever, we use load balancers, and then it's like you put things behind a load balancer rather than doing the service registry. Or am I missing something with the way
No,
that
you
we're
actually
doing
may, if you looked in your load balancer, you may find that they may have a service registry inside them. A great example is Kafka. If you look at Kafka, they actually use a service registry. Zookeeper is their service registry. In the latest Kafka, you can do it so it doesn't require Zookeeper. So they actually store a little service registry directly in Kafka brokers. So they actually federate the service registry across the brokers.
I see.
The concept is still there.
Yeah, so we had used Zookeeper last semester in cloud. Aaron was in that class with me. And so I was just going to ask, like, what's the difference between Eureka and Zookeeper?
They do the same thing, just they're going to be configured differently. With Eureka, it's you'll see how it's configured directly in Java, so it still stays in the Java framework. Yep, but they do basically the same thing. Sometimes these service registries have some extra features in them, and understanding what they are. Another real popular service registry is etcd, which is another popular one. Kubernetes has a registry service built in, so does Docker Swarm. Right, but you guys are probably using a service registry and don't even know it a lot of times. All right. Okay. A load balancer typically will include an API gateway and a service registry together, like Nginx is a great example of that. Some people like to pull them out, pull them apart. And I can see some benefits to that. Mostly if you have a lot of services, hundreds of services, you want to separate those so you can scale your API gateway independent of your service registry. It's the trade-offs. This is where coming up with these architectures is really important, is understanding the trade-offs between them. One of the key things that you get out of a service registry is you're not hard coding host names and ports. The idea is when a service starts up, it is now advertising where it started, and it's got to advertise it somewhere. So in this simple case, it's the service registry. It's saying, I'm service A, here are my endpoints, and here where I am. I'm on host : port. And it says, okay, I know who you are. I will let everyone else know. In fact, I think I show it right here. Here we go. Overview of the service registry. I get a request in. We've seen this before. Showed this last week. Request comes in. But if you look before 1, there's always 0. That's where a service is actually registering itself with the registry. In fact, I'm going to show more in depth here. Oh, I thought I showed it. Yeah, I showed it down there. I'll show that here in a second. It's really important if you're working with a service registry that your service registry comes up first. Why would that be the case?
Well, I'm assuming your services themselves would fail if they came up after the service registry, or if they came up before it, or they should fail. If they didn't fail, then no one would know where they're at.
Very good, Aaron. They should fail, right? That's the number one thing. If you're writing code, right, and you're writing a service and you're architected it for service registry and you don't fail when that service comes up, no one's going to access that service, right? So it's important to have that service registry up, or if you are writing code, if it does fail, to do a sleep, try it again in 5 seconds, then try it again in 10, then try it again in 20, whatever strategy you have, a retry strategy that you have. But you see this a lot in microservice architectures where these services have to be resilient to something going down and retrying. They have to retry. Because even if your service registry went down and you don't want all your services to come screeching down automatically. You want it to be able to reestablish if you can. Okay. So order of startup is important. Service registry first. I would say it could be a toss-up between 2 and 3. Your API gateway comes next, and then your microservices. It depends on how you have your services, your microservices, talking to each other. If they're just going to the service registry and saying, hey, tell me where the service is, then the API gateway doesn't need to come up second. It can come up third. But if you're using the API gateway to communicate between service A, B, and C, which is a mode that you could use, then you need to make sure the API gateway is up first. Okay. How do you force that to happen? Any ideas?
Like using any sort of load balancing?
Well, this is what we call service orchestration. When there's dependencies between services, identifying those dependencies, putting them in place, and then having the orchestrator bring things up in the proper order. If you don't have a service orchestrator, then a nice good old bash script will do a good job for you. Put a little sleep in between some things. It works perfectly fine. It's a good start to a very simple orchestration. But I would use a service orchestrator if you can, either the most popular ones like Kubernetes or Docker Swarm. It's a great example. Okay. Any questions on that? Makes sense to everyone? All right. Okay, let's take a look at the Eureka Discovery Service. First off, Eureka Discovery Service is an instance of a service registry, right? And I can't spell. Look at that beautiful implementation. That is beautiful. If you answer on the test and the written things, implementation, I'll give you extra points for that. So it's an implementation of the service registry. It enables server-side discovery pattern, which we'll talk about what that is here in a second. And clients don't need to know what the back end looks like. This is really important. I think, Elle, you brought this up earlier. The client here talking through the API gateway has no clue where those services are, how they're architected or anything. It's one entry point. And I don't even know if there's 100 microservices back there or just one big monolithic blob back there. And do you care as a client? You shouldn't, right? You shouldn't care about the inner workings of this black box. So if you look at it, everything inside that grayish blue box is completely hidden from the client. They go to the API gateway. They don't go to the service registry. The server-side discovery pattern means that the services themselves are going to talk to the service registry to get where services are. They're not going through the gateway. This is a design pattern that's very well known and very well used, right? The other option here would be turning service A into a client to talk to service B where it goes through the gateway. There's some benefit to that in that you'll get all of the great things that you can do inside an API gateway on filtering and all those other things with predicates, all those other things we talked about last week, if that's what you want. Sometimes you just want something easy and quick and independent of the API gateway. That's the server-side discovery pattern. And this is kind of this is what it looks like, right? This is when backend services interact with each other by using the service registry to identify where those services are, what ports and hosts and ports that they're at. So if I look real quickly here, when service A comes up, it's going to register itself with the Eureka server, and it's going to pass in the endpoints. In this case, V1 and V2 are the endpoints for register for service A. So when service A comes up, it can handle V1 and V2. When service B comes up, it does the same thing, but maybe it is V3. But let's say that when service B comes up, it says, hey, I need to ask service A something. I need to connect to service A and ask something on the endpoint V1. In that case, it's going to look up on the Eureka server, where is V1? Not where is service A, where's the endpoint V1? And the Eureka server is going to come back and say, here's V1, here's how you connect to the endpoint V1. It gives me back a host and port, and I'm connected to service A. It's easy peasy. Right? Now, what this means is, let's say that service A, who has two endpoints, V1 and V2, let's say that I miscalculated how busy a V1 endpoint would be compared to V2. And I really want to separate these two. So I create a new service called service C, which is now going to handle V2. And service A is only going to handle V1. So those services come up, they register themselves independent of each other. Service A has V1, service C has V2. When service B goes and says, hey, I need this endpoint V1, does it know who it's connected to? No clue. All it knows is here's my connection string and V1, and it's off to the races. It's service A. Or if it said V2, it could be service C. So what this means is that my microservices are now decoupled from my deployment model. This is very, very important, because if you do have them tightly coupled, that means that you're going to have to go change service B code to know how to connect to this new microservice sitting out here. Instead, all we've done is we have relegated the responsibility of that service lookup to the Eureka server, which makes our life a whole lot easier. It means B is decoupled from A. It's only coupled through the interface. Right? And I don't even know if service A is going to be the one actually handling V1 in the future. And I don't care, just as long as I'm getting back the same type of information. So a huge benefit is decoupling using a Eureka server like this. Another name for Eureka server, again, is a service registry. Quick question, see if anyone was paying attention. What are some other service registries that are common out there? You guys know these. Throw some names out. It has to be someone other than Aaron, L, Hamza, or, oh, Jonathan hasn't said anything yet today. So one of you other guys, speak up, or gals.
So I know before we were talking about how Kubernetes uses it. So
Kubernetes. Good. Anyone else? Reed, Ronald, Andrew, Nigel.
Cloud Map?
Say that again, Ronald.
Cloud Map, AWS Cloud Map.
Oh yeah, you know what? That's a service registry. That's a good one. I didn't even think of that one. That's a good one. Anyone else?
Doing a project keeper in another course.
Oh, oh, really? They're using that course?
Absolutely.
That's awesome. Etsy, EETCD, Etsy is
And
one.
console, am I saying that right? Console?
Console, CONSUL.
Mhm.
Yep, that's a type of service registry. Yep. Another Zookeeper is a big one. So these are, you see a lot of them. They're very simple. They're very simple services, but very important, as you can tell. All right, let's keep going. All right, now we're going to talk about getting closer into some of the code here. There are two ways to set up configurations for these services or service registries. One is an imperative declaration, and the other one is declarative, right? With imperative, you're explicitly giving instructions on how this services, the microservices are mapped, right? They're tightly coupled because the service must interact directly with the registry. And a lot of times it's hard coded inside the registry, right? It gives you a lot of control where I can say service A will always be started up on host A, B, or C. But it also means if there's problems, or if, heaven forbid, someone come in and change your naming scheme in your data center, that could be an issue, right? There's more maintenance because you have to handle failover and recovery in the service registry itself, right? You also have to have state consistency, and a lot of times you'll see these service registries that are imperative configurations where they're pooling by sending health checks out to the individual microservices. Are you still there? Are you still running? I'm going to restart you if you fail, and things like that. The concept here is that imperative declarations mean the system is stupid, but you're smart. So you've written all the logic into the actual orchestration of those services. So that's an imperative declaration. A declarative declaration is where we describe the outcome, not instructions on how to do things, but what we want it to look like. So services are described with config files. They're loosely coupled. That means I don't manually register the services myself, that when a service comes up, it registers itself automatically to the service registry. They tend to be more self-healing. I have an orchestrator that's separate from the service registry a lot of times, that is monitoring either by sitting on a port, looking for a socket drop and saying, hey, I just lost connection to the socket, meaning that service just went down. I need to do something, or they pool. Those are different options. And then they're much easier to automate. They work really well with cloud native environments, right? In this case, the system is smart, and you as a developer, you don't care. It just works for you. So we're not going to do imperative configurations. We're going to do declarative configurations with Eureka. Okay, does this make sense? Everyone got this? All right, I will bring, all right, I got thumbs up. That's what I wanted to see. Okay, thumbs up. All right, let's go back to the slides. How did I do this? All right, let's take a look at declarative configuration. So in your application development, and this will be in the application file that you create, you're going to enable the Eureka server just with one of the Spring annotations that we're using. It's really that simple, saying, hey, this is a Eureka server. Enable the Eureka server. Here's my Eureka application, whatever the case may be. That's it, to say, hey, that's what this is. Then I have a YAML file which will describe the Eureka service itself. Remember, this is a microservice. So I've got to put in there a configuration file for the YAML, for the microservice using YAML. Okay. This first top part of this, I'm specifying which port it's listening on. And I'm also specifying the application name, Eureka here. So that way I can easily look up that microservice. Its name is Eureka. I can attach to it and do whatever I want. The second half of this is important as well, especially when I come down to client. In this case, I'm saying when this microservice comes up, don't register this microservice with the Eureka service. Don't do it, right? I could do this if I was setting up a mesh of Eureka services that were communicating with each other. It becomes a little more complex in the configuration, but it's totally doable, where I can have a federation of Eureka services and I'm passing service information between them, right? And querying across the mesh. That is possible with Eureka services, but we don't want to do that in this course. That just makes things even more complex. So make sure when you're setting this up that you are putting in there register with Eureka as false. This is all we're saying here, is that this microservice that's running the Eureka service is not going to register itself to other microservices that are Eureka services or even itself. Okay, does that make sense? Any questions? Good head shakes. I got to come back. I got to bring this back up. How do I bring my little pop-up? I can't remember how to do that. I'm going to stop sharing and reshare, and that should fix that for me. Okay. What happened to my share button? There it is. All right, here we go. All right. Okay, next, let's take a look at the individual microservices. So if I have service A and service B and service C, in the microservice configuration for them, I'm going to specify the port. Here, I put 0. That's not right. That should be like 9,000 or 3,000, depending on what port you're going to put this at. And then I'm going to specify in a section for this microservice called Eureka client enabled. I'm going to say true. And I'm also going to say what name this microservice is. In this case, service A. So it's important that you put in there that I want to attach to Eureka, right? I'm saying this is a Eureka client. This microservice is actually a client of the Eureka service. This will tell it you need to connect up. You need to be able to, hey, be able to register yourself to the Eureka service itself. Okay. Any questions on that? You guys get that? Make sense?
Yes, I do see there's a misspelling of Eureka on the orange thing.
Oh, thank you. I will fix that. Spelling is not my favorite thing. That's why I code, because it underlines all of my misspelled words. Or I have variables that are misspelled throughout all the code, but that's okay as long as they're consistently misspelled, right? Okay, now let's talk about the API gateway.
I have a quick question. For the application name, are there any conventions we have to follow?
You know, with Spring, I'm trying to remember if we can have uppercase. Traditionally, microservice names start with a lowercase. In the Docker realm, you can't have uppercase for microservice names. So they use dashes or underscores. In Spring, I'm not sure. I'd have to look that one up. Which, hey, we can look up here in a minute when we open up ChatGPT.
Cool. Thank you.
Something Hamza is going to find out and tell the rest of the class in class next week. Way to go. All right. Good question. Any other questions on how to register your own microservice? All right. API gateway. Guess what, guys? An API gateway is what? It's a microservice. So looking at this file, do I want to register the API gateway with the Eureka service?
If it's a microservice, I'd say yes.
Yeah, that's what I would think too, but the answer is actually no. I'm not going to register it, but I am going to connect to it. So in this case, I still need to make sure that my API gateway is a client of the registry service, but I'm not going to register it with the Eureka service. Why would I not want to do that, Tamayo?
Decoupling?
No, not really. I mean, they're already kind of decoupled.
If you have, we talked about not specifying the port and all that stuff, so maybe you don't want to specify those properties in there.
Oh, why would I not want to specify those properties in there?
Well, if you're trying to, the whole thing with containerization is you're trying to build these mass zombies machines, and if you suddenly specify on one port, those other millions of services will have the same port, and there could be a communication disaster.
It could be, yeah, it could be. So the only case that I would register, I wouldn't even register it because it is going to be a disaster, right? Because remember, the API gateway has all of the endpoints in it, right? All the endpoints. So most of the time you don't want to do that. The only case I could see where you might want to do that, you have to be very careful, is when the microservices themselves are going to use the API gateway because they don't know where it is unless they ask the service registry, where's the API gateway? Right? So that's going to be important. But most of the time you don't want to. But you do want to make sure that it is a client. So you need to enable the client, but not register it. So that's the key thing here. Okay. This is the gateway YAML configuration. You guys may need this in assignment 2. I don't know if it's in A or B, but you will need it. Okay. All right. Any questions on configuration of the service registry, specifically Eureka? No? Okay. How many of you have already looked at assignment 2A? By raise of hands, you could do a hand, the virtual hand raise. Anyone looked at assignment 2A? No, not yet. Okay. So it would be good to start looking at it soon. I think we have it due next, 2A is due next week. So we are going to use something called a retrofit library, right? The retrofit library is going to make it much easier to write proxies for your application, right? It just makes it a whole lot easier by using annotations, and it gets rid of a bunch of boilerplate code to make it just much easier to work with, right? It does a lot of automatic parsing in JSON for us. It handles both asynchronous and synchronous requests. It's type safe. There's logging built in. It's really nice to use, but it's something new you guys have to learn. And it is going to be an assignment 2A. You are supposed to use retrofit to create proxies for the movie recommender. And it will make your code much easier to maintain and read later on. In order to help you guys out with this, because this is what it looks like. Here's an interface for an API service. So if this was service A and it had endpoints users, a get, post, and put, this is what the code could look like for that. Now, we are going to help you guys out with this, I'm going to show you a fun little trick that we can play with ChatGPT. It can really help us out here, right? So the first thing you'll want to do is go find basecontroller.java. It's in assignment 3. Here's the path. Okay. So if you go and you find that file, you can easily attach that to ChatGPT. And you don't need to purchase. You got to be careful how much you use in one day, but let me show you what that looks like. So I can upload files right here, and I can upload that file from the computer. And I'm going to upload, let's see if I can quickly find it. C1. This is where typing in front of a crowd is always dangerous. Assignment 3. And it's in recommenders, source, main, edu, Vandy, recommender, common. It's the base controller Java file. So I'm going to add that in there. And then the next thing I'm going to do is I'm going to ask this prompt. I'm going to say, please analyze the Java. Oh, wait, it's not going to let me do this, is it? All right, please let me analyze the Java file containing in the Spring base controller and generate a corresponding retrofit to interface named quote API that I can be used to invoke remote method calls in the controller. So I'm going to drop that prompt in there. And let's see what kind of code it's going to spit out. It's going to spit out some retrofit code for me. And look at all that code that it spit out here for me. Now, not only does it spit out the code for me, it also a lot of times will tell me why it's doing it. And it also tells me what else I need to continue to change, like call object as a placeholder for return types, replace object with the appropriate response model. So I happen to know what those response models are. So my second prompt here is I'm going to say here, please regenerate quote API interface with the following changes. I'm going to change the generic parameter, call, whatever's in call with list quote for all the call return types. And I'm also going to add the path route name, and that is misspelled. I need to fix that before I send it in. Add path route name to string route name as the first parameter for each quote method. So I can grab this whole prompt here and I'm going to jam that in there and see what we get. Okay, this is looking a lot better to what I'm used to working with here. Now, what else is wrong with this code that you guys can see? First off, can you see this okay? Is it big enough? Is that better? What else is missing in this code? Just right off, just blatantly missing. That we need you guys to always do in all your code for assignments and hopefully in the real world too. Before I show you on the next slide, what's missing in here?
The code comments.
Comments. All right, should we ask it to do some comments?
Yeah.
All right, let's ask it to do some comments. You know what? Let's do the comments. Let's do the comments now. We'll do the comments. Generate comments. All right, and then we're going to create another a bean. All right, so let's add comments in here. Quote API interface. All right, let's see how it does on generating comments. It did pretty good. Look at that. Look at that. It did pretty darn good, don't you guys think? Do I completely trust it? Not completely. I may want to go back and clean some things up. Okay, now let's go a little further with this. All right, the next thing I want to do is I want to create a Bean Factory method called getQuoteAPI, and I want it to return the quote API interface that has a base URL set to the Java string gateway base URL. Another typo there, Karen. All right, let's take a look at it and see how this one works. All right, so I'm going to create a Bean Factory method. Look at that. There's the quote API config. All right, that looks pretty good too. It's all commented. Looks really nice. So, guys, I want you to use ChatGPT to help you in assignment 2A, because it can help you generate a lot of code very quickly. Now, as some of you have already used it, in fact, I'll send the question out there. Who has already used ChatGPT in some of their previous assignments? I know some of you have. I've seen it. You should be raising your hands. It's okay to use. In fact, I want you guys to start using it more to help you write good code. But if someone and you know who you are, right, who used it and it took you astray, do you want to elaborate on what happened, or do you want me to elaborate? You can either stand up and be heard, or I can elaborate on what happened. Anyone brave enough?
Yeah, well, I had used it trying to like help just get set up on for 1B, and it really like messed up my whole, I don't know.
Repository,
All
yeah.
of my dependencies got really messed up, and so I really like got lost, like, and so messed up with everything. I couldn't like really turn in anything good for my 1B, which I'm still working on. It's almost done, but I just have a few more tests that I need to get to pass. But yeah, so that's why I haven't been able to start on 2. But yeah, like I was sad because I felt like really good off of 1A, and I was like, okay, well, let me put this in. Let me see if it can help me get this set up, because I was just trying to take it from instead of, well, now I'm doing better with using different branches, like building off of stuff. But I had built a new repo, which was my issue, and then trying to like start over again and piece things back in, and I had messed it up. So, yeah.
So the lesson I want you guys all to learn with ChatGPT and what Elle went through is you have to be able to prompt it properly. You have to ask it the right questions. If you don't understand the core concepts and you just go and say, hey, I need this, this is the assignment, I need it done, it may lead you down a path that you can't recover from very easily. You'll get yourself wrapped around an axle that will be hard to recover. So make sure when you're prompting that you're asking the right questions, that you're using, especially for the assignments that we have, that you're using the material from the class, right? From these lectures or from the lectures that you're seeing online, because we're trying to get across to you guys different techniques to use in Java that use certain design patterns. So if you know what the design pattern is called and you know the library that might be used, you can feed that to the prompts and they'll be able to help you get that code faster. I talked to Dr. Schmidt about this when I took the class from him, and we had a great conversation that ended up being in a podcast that we did around Gen AI in education. He and I both agree that the future is going to be having very smart people like you guys being able to leverage a Gen AI to help you get code out faster. Because we don't need more coders. We need software engineers. We need computer scientists, people that can think beyond typing, right? Too many of our languages, like Java, is a great example. There's so much typing that goes that's involved in doing it that we sometimes lose the architecture and design. And this is where if you understand the architectural principles and the design patterns, you can really leverage ChatGPT to help you move quick through these things, and it will help generate some of these codes. I truly believe in the next 5 to 10 years, you're going to see some new languages evolve that will be much more terse and more declarative. That we're going to see some really big changes in the way that we interact with computers, and these architectural elements are going to become even more important. So make sure you're understanding these principles more than just the coding aspect. So use ChatGPT as your friend. Make sure that you're informing your friend properly. Otherwise, it could lead you astray. So that's kind of the tip of the day for that. Okay, so let's go back and talk about some other principles, unless there's any other questions on ChatGPT and retrofit. Any questions on that? No questions. All right, here's another tip. Ask the code that you've created with ChatGPT, ask ChatGPT or another Gen AI like Claude or Perplexity or Gemini or Copilot. Ask them to score your code that was generated and to find errors in it. Okay, that's another good tip. You can even ask it to come up with its own rubric. Tell them you're taking a master's level course on microservice architectures in Java, and these are the things we talked about in class, and have it score your stuff. You will be surprised, and it will give you some really good ideas, right, on how to make your code even better. Like, for instance, I mentioned it to some of you guys, I think everyone, instead of print screened or print ln, why don't we use a logger instead? And that'll be one that pops up. Or be more defensive programming, check values as they're coming in for null and things like that, right? Those are some tips that I think if you ask ChatGPT, it'll tell you the same things. Okay. All right, let's dive into the next part, which is reactive programming, which I want to go over real quickly, and then we will call it a day. So let's see if I can remember how to do this again. We'll do share. Okay. All right, back to Beast here. All right, reactive programming. When we talk about reactive programming has these 4 key principles. It needs to be responsive, elastic, resilient, and message-driven. That's the concepts behind reactive programming paradigm. We're going to talk about each one of these, and we're going to talk about what it looks like, the paradigm actually looks like. So many of you, I don't know how many, but I'm assuming some of you have used ETL or ELTs before. Anyone? You know what I mean when I say that? Right. Okay. It means I'm going to extract, load, and transform, or extract, transform, and load. There's several options. This is all about data pipelining, right? Reactive programming is the paradigm that data pipelining fits into. Data pipelining is an instance of reactive programming. Simply put, it is when asynchronous programming paradigm that looks at processing streams of data and propagates changes throughout the streams. You guys have already been doing some reactive programming because we were forcing you to use streams and to use functional programming, which fits very well into this reactive world. And another way of looking at it is this way here. Okay. It means that I've got some asynchronous operators, right? That I'm going to take a stream of data from a publisher. I'm going to run it through operator A, then through operator B, and then out to a subscriber. These operators are run, they can be run massively in parallel, and they can be run asynchronously, where I've got A might be blocking before B can run because it's the dependency, but you can have very complex reactive trees of these operators that are fitting in here. There are some paradigms outside of Java that do this. A lot of the message buses, some of the more modern message buses like Apache Pulsar, allows for operators to be injected into the data streams that you're producing, data streams that are running in the message bus. Okay. Operators are mapped transparently to one or more threads. We've kind of done a little bit of this with our task scope stuff that we worked on, same type of concept. And the interesting thing to look at with reactive programming is this little thing, and I love this, so I just completely stole it. I can represent anything as a data stream that can be created on any thread, functionally transformed and consumed by everyone on any thread. So if you notice, when I'm streaming data, it's being chunked as I'm going through. So I can either grab chunks of data as individual words, or I can grab them as sentences or paragraphs or anything like that. But they can be consumed by everyone on any thread. I'm using a message bus concept here. So instead of just passing it from one to another, where it's sequential, I am passing the data stream, the transform data stream goes into the message bus where other operators are looking for that, and then they can make that transformation and come through. This can happen all in the same process, or it can happen across multiple processes even. There are some reactive programming paradigms that are out there that are highly distributed, that can be run over very large networks, even in semi-disconnected or intermittently connected networks as well, which is super cool when you look at that sort of stuff. Right? Okay, so when would we use reactive programming? Lots of places to use it. Anytime I'm interacting with something that is asynchronous or that's not necessarily timely in getting information. So like processing user events like mouse movements, clicks, or touch events on touch screens, or even GPS locations on phones and things like that. Or if I'm responding to any high latency IO bound events, like getting things off of a disk or off of a network or things like that, right? Those are great places where you'll see reactive programming, especially on a message bus, where I don't know when the messages are going to arrive. They're just going to arrive whenever. I'm not guaranteed. I'm not guaranteed when. Okay, and also they're very useful when communicating between microservices in microservice environments. Right, the reactive programming techniques. All right, let's talk about responsiveness. So the paradigm behind this is that I can provide a rapid and consistent response times, even though I might not, the input coming in might not be consistent. Like moving a mouse. How often, unless you have a program that sits there and spins around, which I know some of you do, right, that spins around and keeps your mouse moving, so work thinks that you're actually working. I got one of those running on my work computer right now, of course. No, I don't. But consistency in response times, not consistency in input. But so when something happens, I want to make sure that I have a quality of service that, hey, I'm going to get a response in a certain amount of time. So I need to be responsive. And I need to reliably set those upper boundaries and also lower boundaries to prevent delays or what's the right word? Or misinterpretation of data as it's moving through these pipelines. Okay. The next one is resilience. So the system remains responsive even when I have failures. So let's say that service A is doing operator F. It's transforming, I'll do a military thing. It's transforming radar data into object detection data. And service A crashes. Okay, all of a sudden, my resilience is gone, right? But with this, service A, someone else can pick it up on a message bus, another service A running will just pick that message up and run with it, and I'll be okay. Right. So resilience is key in these architectures. So making sure that your microservices that you are running are independent of how many instances of them are running at the same time. Right. That will become very important. Also, if I have some failure of some operations, it shouldn't bring down the entire system, right? Unless that's the behavior you want. You had a great case of AWS where they had a high dependency on CloudWatcher, I think CloudWatcher. It was actually a microservice inside CloudWatcher that was pooling all the events, all of the microservices. And it went down, and everyone was relying on it to notify them that a service was down, but it was down, and all the other services didn't know what was going on. So in that case, that was a bad design, not very resilient. So we need to make sure that we have resilience. Okay. The next one is elasticity or elastic, which means I need to be able to auto scale so that I can handle more load if I have events coming in where I've got, let's say, a concert, and the concert's kicking off tomorrow, and I have something that's keeping track of the participants at the conference where they can register for things or buy food or things like that. That's going to be important that I can auto scale and take 100,000 hits instead of the 10 or 20 that I've been having the week before that. So it still needs to be responsive, and it needs to be able to handle workloads and both grow and shrink depending on the workload. So that's elastic. The last one is message driven. And this is really not a principle as much as it is an implementation. Or an implementation detail. It really helps provide loose coupling between the operators or the microservices that are serving up those operations, and isolation between the different components in the system. In this type of architecture, if I am service A and my job is to convert radar data into object detection data, and that's all my job is, and I publish that I found an object, I don't know if it's a good object or a bad object. That's service B's job, is to sort objects based off of threat detection, right? So it does threat detection. Service A doesn't know. It's just putting the message out there on the bus. Service B, it knows, hey, I'm getting object detection data. It doesn't know where A is from. It doesn't even know that it came from radar. It could have come from anything. So that implementation of the individual services are completely decoupled. In fact, they don't even need to know what their REST interfaces are, just what the message what the agreed message cargo holds. That's it. So it very much decouples the individual services from each other. Okay. You guys should be able to, in the next test, be able to describe those specific, the 4 key areas of responsive or reactive programming. Okay, responsiveness, resilience, elasticity, and message driven. In ChatGPT, they use different terms. So, and it depends on how you ask ChatGPT. They may use different terms every time you ask it. So be careful, is what I'm saying. This is what we want to make sure that you guys understand. Okay. Any questions on reactive programming? No questions out there? Okay, guys, that's it for the lectures part of today. I've given you a lot of information. I will make sure that this slide deck gets posted and also the video, so you guys will have it. If you know other people in the class that weren't here today, please let them know to take a look at the lecture, especially around ChatGPT. It will help you immensely in assignment 2A. It should help you write a bunch of code for you. You just may have to go and clean it up here or there, or get better at prompting ChatGPT to write code for you. Okay. All right. If anyone needs to stay after, I am available. If not, then you guys have a great evening. Try and stay warm. I get to go to a soccer tournament to watch my granddaughter play. So I'm going to bundle up because it will probably get cold. So
Hey, just to ask again and kind of refresh about the submission for assignment 1. Are we just like bundling everything?
yep, make sure that you put in assignment 1. Just all you need to do is go make sure that you have 1A, 1B, and 1C. Any changes that I suggested, put in those directories and send me the link like you always do. For those of you that have already made those changes, you're done. Hand it in. Some of you already have, and you're good to go. Okay. And I'm going to try and get all those graded by Saturday morning. We'll see if I can pull it off because there's a lot to sift through. If not, it'll be you guys will have it Sunday afternoon or so. Okay. Any other questions? All right, I'm going to stop the